Okay, we've got our video here on transformations of functions. Please don't forget those parent functions that we've talked about. We've talked about f of x equals x, or it'll equal like x squared. Remember your quadratics, or x to the third. Or we've talked about absolute value of x, or the square root of x. And then we've also talked about like exponentials like 2 to the x. And don't forget like the shape that they all make, please, is just a review of that. Remember these are just linears that form these straight lines. We've got quadratics that are the u's, cubics, which are these little squigglies. We've got our absolute values, which are the v's. And then don't forget our square roots are the story of our lives. They start in one spot and then go one direction. And then we've got our exponentials here, these exponentials that go here and then up, like so. So remember their shapes. Remember their parent equation as we talk about those transformations. What we want to do is we want to be able to move them and shift them and flip them, rotate them, that kind of stuff. Is what we're going to be looking at, is moving all these cute little equations different ways. And we can do that a lot of different ways of doing that, okay? So generally speaking, when we want to shift something right or left, we're going to affect the inside. So like a horizontal shift is what they call that. And it's really, if you want to think about it, it's shifting it left or right. We're going to add or subtract inside, and we'll look at what that means in just a second. If we're going to shift something up or down or vertically, so a vertical shift, and that's again, that is up or down. We are going to add or subtract to the outside, is what I think of that. And again, we're essentially affecting the x and the y, depending in that case. The other transformations that we do have reflections. Specifically, we have a reflection about the x-axis. And to get that, we're going to times a negative to the outside. So we're going to times by a negative on the outside. And I'll show you what that looks like. And if we reflect about the y, it's going to times by a negative on the inside. So to reflect about the y-axis, we are going to times, whoops, that's an axis there. We are going to times by a negative on the inside of our function. And then the only other transformation we're going to talk about is a stretch or a compression. A stretch or compression is when we times, and these are vertical stretches and compressions. So vertical stretch, we are going to times by a number greater than 1. So that number has to be greater than 1 that we're going to times by. If it's less than 1, then it's a compression. Or sorry, yeah, if it's less than 1, it's a compression. And it has to be obviously greater than 0. So between 0 to 1, that's a compression. I'll show you what that looks like as well. So what I want you guys to be able to do is look at a graph and be able to see a transformation. Look at an equation and be able to tell a transformation. And then be able to like apply a transformation to either a graph or to an equation. So we're going to start with some of these examples right here. So I've got 6 different examples here. This top left one is an absolute value parent function. So it's changed the absolute value by 4 and by 1. If anything on the inside that's added or subtracted, again, inside added subtracted moves it left and right. The inside is always opposite, or some people will say the inside lies. So you would think this would go right 4, but it actually goes left 4 because of that inside. The inside's always opposite. And then when you add or subtract to the outside, that's a vertical shift, so up or down. And so this one's going to be moved down 6 in this case. And again, the parent function for this is an absolute value function. But we're just naming those transformations. If I look at this one, my parent function is x squared, or a quadratic. And again, this 6 is on the inside, the 4 is on the outside. Adding does the opposite, so this is going to, again, move it left 6. And then the minus 4 is going to move it down 4 in that case. So inside is with those parentheses. If I'm talking about a root here, so this one I've got a square root. Again, its parent function would be the square root of x. It's underneath or inside the root is the inside, and then outside is obviously outside. So this is, again, going to move it left 5. I apologize, I do not have any examples of minus. So if this was a minus, it'd move it right. And then we've got down 7 here, okay? This one has our same thing, our absolute value, so we're going left 2 and going down 7. But if you notice, we have one other transformation, this negative out front. The negative that's multiplied on the outside reflects about the x-axis. So all I'm going to say is this reflects about the x-axis. Is what I'm looking at for that one. All right, we got a bunch of stuff going on this. So if you look on the inside, I've got minus 11, which that means we're going right, because the inside's always the opposite. And it's going to go right 11, and this plus 6 is going to move it up 6. The negative, these are two separate things. The negative is what we did on the last one, so it's going to reflect about the x-axis. And then my 2 that I have here is actually going to stretch this equation by a factor of 2 for that. So we want to just make sure that we have that stretch by 2 on that equation there. This very, very bottom one, if you notice, I have no parent function. It's just telling me, generally speaking, what's going on with any type of function here. So it's not like putting an absolute value or a quadratic with it. It's just telling me, hey, I've got a general sense here. So if I look on the inside, if I subtract by 8, that's going to move it right 8 regardless of whatever parent function it is. The plus 19 is going to move it up 19 regardless of whatever function it is. And then this negative is just, again, that's multiplying on the outside. If it was on the inside, it would be the negative on the inside with the x is where it would be. So this is going to reflect about the x-axis for this. We want to make sure we keep those straight. Like this, again, this one just does not have a specific function. It's just saying any type of function there. One thing to keep in mind, if I have my exponential, inside is going to affect the x. So if I had like 2 to the x minus 9, that is moved. That's like the inside right there. If I have like a plus 5, that's the outside. So inside's here, outside's here. So inside's with the x, outside's just without that. So this would move it right 9, and then it would move it up 5. So one thing to keep in mind with that, multiplying or doing something with that would put a negative right here. That makes it reflect about the x-axis. If I have the negative right here with the x, it reflects about the y-axis. So with that one, I'd have both that I just wrote there. So just keep in mind, exponential is the one that's kind of sometimes harder with students. We've got our absolute values that are good. Our cubics are good. We just have the 3 instead of the 2. One of the last thing I want you guys to be able to do is look at a graph and be able to tell the transformation and the parent function. So this parent function is a square root. And I know that because of this starting point, and then it goes this off in this one direction by itself. This point is moved from here, and it's usually down here. If you remember, the parent function usually is right here. Okay, so we have moved left 1 and up 3. So to write that equation, if I wanted to write the equation, I'd go x plus 1, because it's always the opposite. I know this is minusing and going left, but remember, this moves it left 1. And then I'm going up 3, so I'm going to go plus 3 on the outside. That's how it actually write the equation. Again, this is moved left 1, and it is moved up 3 for that. Okay? And my parent function is a square root function that I've got here. This other one on the right, this is a quadratic. And that means its parent function is x squared. This has been moved left 3. It's been moved down 1, and it's been reflected, if you notice, because usually it's straight up and down. Usually the parent function's right here. And so this has been reflected about the x-axis. So I just need to write my equation for that. So I'm going to have my parentheses with my squared here, because that tells me it's a quadratic. The root tells me it's a root, but this squared is going to give me the quadratic. I put my x there. It's moved left 3, so that means I'm going to go plus 3. Down 1 means I go minus 1. And then reflect about the x-axis, I have to multiply by negative on the outside there. So I know this has not been stretched or compressed, because usually if there's my top point, and if I go down 1 over 1 and I have those intersecting, then that's exactly what I want. If it went down 1 over 2, then I'd know that I have some sort of stretch or compression there. So that's what we're looking for with this. This has been your math moment with Mummy. Adios.